We want to solve the simultaneous equations. 3x minus y equals 10 and 4x minus y is 13. So we have 3x minus y is equal to 10, and we'll call this equation 1. We also have 4x minus y is equal to 13, which we'll call equation 2. We have the same number of y's, both of them are minuses, so the signs are the same. Signs same mean we're going to subtract the two equations. I'm going to do equation 2, take away equation 1, choosing to do it this way round as we have more x's in equation 2 than we do in equation 1. 4x take away 3x is just 1x, which we write as x, minus y minus minus y becomes minus y plus y, which is 0, so we have no y's. 13 take away 10 is 3, so x is equal to 3. Substitute this into one of the original equations. In this case, I'm going to use number 1. If x is 3, then 3 3's are 9. So we have 9 take away y is equal to 10. Taking 9 from both sides gives minus y is equal to 1, and therefore y must be equal to minus 1. So x equals 3 and y equals minus 1 is our final answer. Once again, we need to check this answer. Substituting into 1, if x is 3 and y is minus 1, we get 9. Take away minus 1, which becomes 9 plus 1, which is 10, which is correct. Looking at number 2, 4 3's are 12. Take away minus 1 becomes 12 plus 1, which is 13, which is also correct. Now consider part B. Our simultaneous equations are 2x plus y is equal to 12, call this number 1, and 3x plus 2y is equal to 17, call this number 2. Note that we have a different number of x's and a different number of y's. But we can change this by doing the following. Take equation 1 and multiply it by 2. 2 lots of 2x are 4x. 2 lots of y is 2y. And 2 lots of 12 give us 24. Call this equation 3. And number 2 is 3x plus 2y is equal to 17. We now have the same number of y's. The signs are the same, and therefore same, subtract. If we do equation 3, take away equation 2, 4x take away 3x is just 1x. The y's, of course, will disappear, and 24 take 17 is 7. When we substitute back in, always choose to go back to one of the original equations, either 1 or 2. In this case, I'm going to substitute into number 1. If x is 7, 2 7s are 14, so I have 14 plus y is equal to 12. Taking 14 from both sides gives y is equal to minus 2. So my final solution is x is 7 and y is minus 2. As usual, we should check. Looking at equation 1, with x is 7 and y is minus 2, we have 14 plus minus 2, which is 14 take away 2, which is 12, and this checks out. Looking at 2, 3 7s are 21, plus 2 times minus 2, which is minus 4, is 21 take 4, which is 17, and this also checks out. We now have 2x plus 3y is equal to minus 1. Call this equation 1. And x take away 2y is equal to 10. Call this equation 2. Once again, a different number of x's and a different number of y's. We could multiply equation 2 by 2, and if we did so, we'd get 2 times x, 2 times minus 2y minus 4y, and 2 times 10 is 20. Call this equation 3. Equation 1 is 2x plus 3y is equal to minus 1. We now have the same number of x's. Remember that the signs on these x's is the same, and if the sign is the same, then we subtract. Let's do equation 1 take away equation 3. The x's, of course, will disappear. We then have 3y minus minus 4y. 3y minus minus 4y is going to become 3y plus 4y, which is 7y. So we have 7y minus 1 take 20 is minus 21. So y is equal to minus 3. Substitute back into an original equation. I could choose either of them. In this case, I'm going to substitute into number 1. I have 2x. If y is minus 3 plus 3y becomes minus 9. This is equal to minus 1. Add 9 to both sides gives 2x is equal to 8. Divide both sides by 2, and I get x is equal to 4. So my final solution is x is 4, and y is minus 3. We now want to check. For number 1, 2 4s are 8, 3 lots of minus 3 are minus 9, 8 take 9 gives minus 1, which is correct. In number 2, x is 4, take away 2 lots of minus 3, so take away minus 6. This becomes 4 plus 6, which is 10. This checks out as well, so we know we have the correct solution.